Hello everyone, welcome to this demonstration of Sacroiliitis Sacroiliitis Classifier. This project was developed by the Qatar University research team led by Dr. Amit Kandakar and supervised by Dr. Mir Al-Hamed and Dr. Samar Al-Imadi from Hamad Medical Corporation. Sacro VLM-RAG is an automated system that classifies sacroiliac joint MRI scans to detect sacroiliitis, which is the key imaging finding of axial spondyloarthritis. The clinical problem we are solving is significant. Diagnosing sacroiliitis from STIR MRI requires considerable expertise, and patients on average wait 7 to 9 years before receiving a correct diagnosis. Our system automatically reads the MRI and gives a binary answer, either MRI positive for sacroiliitis or MRI negative/non-specific, along with a full explanation of why it made that decision. The pipeline works in 3 stages. First, each MRI slice is described by LAVA, a large vision language model using a structured 9-field prompt. Second, those descriptions are embedded as vectors and matched against a knowledge base built from the ASAS handbook using FAISS similarity search. Third, a 3-layer correction architecture refines the decision using patient history signals and ASAS grounded override rules. Now let me walk through the web application. You can see the full interface here, built with Streamlit and running on Google Colab. On the left sidebar, the green badge confirms the Colab GPU backend is ready and connected. Below that, the 3 possible output classes are listed. MRI positive sacroiliitis in green, MRI negative/non-specific in orange, which covers conditions like osteitis, condensans ilii, mechanical bone marrow edema, and degenerative changes, and unknown in gray for cases below the confidence threshold. The steps panel on the sidebar guides the user through the process. Upload your MRI slices, add patient history optionally, click Run Classification, and download the result as a JSON file if needed. Now I will start the demonstration. I'm clicking the Upload button and selecting the 18 STIR MRI slices from my local folder for Case 1 from the ASAS Online Case Library. You can see all 18 slices have loaded successfully. The thumbnails show the semicoronal STIR views through the sacroiliac joints at different depths. The green bar confirms 18 slices at approximately 10 minutes on the T4 GPU. Now I will move to the patient history box on the right. I am pasting the clinical information for this patient, which includes inflammatory back pain, HLA-B, 27 positive status, good initial response to ibuprofen, and no history of inflammatory bowel disease. Now I will click Run Classification to start the pipeline. The system is now processing. You can see the processing screen with the progress bar. The pipeline is running vision inference on each of the 18 slices using LLAVA, which is the most time-consuming step as the model describes each slice individually on the GPU. After that, FAISS retrieval and LLM reasoning complete very quickly. The classification is complete. You can see the classification results section is now appearing. The result banner shows MRI positive sacroiliitis with a similarity score of 0.838, 61% positive slice votes across all 18 slices. Let me walk through the 4 result tabs. The first tab is RAG scores. You can see MRI positive scored 0.838 and MRI negative scored 0.450. The system also detected a history signal, IBD context, from the patient history we entered, which shows the layer 1 signal extractor parsed the clinical notes and adjusted the score accordingly. The second tab is reasoning. This is the full structured output from the VLM differential analysis. The class is MRI positive sacroiliitis with high confidence. The key STIR evidence is hyperintense signal in the periarticular subchondral bone marrow adjacent to the sacroiliac joint with extensive involvement. The evidence against the negative class lists all the non-inflammatory patterns that were not found. No dark triangular iliac signal, no band crossing the sacrum midline, no small focal caudal signal. The third tab is ASAS reference. The system matched this case to box 10, MRI positive, bone marrow edema on STIR. The full ASAS criteria description is shown here, confirming that hyperintense signal must appear on at least 2 consecutive slices with intensity comparable to blood vessels or spinal fluid. This is exactly the reference that grounded the classification decision. The fourth tab is timing. Vision inference took 587.6 seconds, face retrieval took only 141.3 milliseconds, and LLM reasoning took 34.6 seconds. This confirms that the retrieval step is essentially instantaneous. The GPU time is consumed entirely by the vision model. You can also download the full result as a structured JSON file using the download button, which is useful for record keeping and further analysis. Finally, pressing the clear button resets all inputs and clears the uploaded slices, returning the app to its initial state ready for the next case. To summarize, Sacro VLM-RAG takes raw stir MRI slices, describes them using a vision language model, retrieves the closest matching ASA's handbook reference, and produces a binary classification with a full evidence-linked explanation. It runs on a free Colab GPU with no fine-tuning required and achieves high accuracy on the ASAS expert-validated case library. Thank you for watching.